And we are live.
Okay. So shall I begin by providing an overview of the project and sort of some of the areas in which we see value in research, and then from there we can potentially ask questions, have members of the group ask questions.
Yes, go ahead, Ty. The stage is all yours and Braden's.
Okay, very cool. So for those who haven't met us before on the sessions which we hosted yesterday at around this time, my name is Ty Everett. I am the founding president of Project Babbage, which is a Bitcoin infrastructure company providing low-level plumbing and protocol architecture for applications created using the Bitcoin SV blockchain. And with me is Braden Langley. He is my CTO. So we work closely together on developing Bitcoin infrastructure, essentially. And the value that we provide for the industry is that we remove the need for application developers to reinvent the wheel when it comes to integrating distributed ledger technology into their platforms and solving for particular business use cases. So by using a layered approach to protocol standardization and then technology development at each layer, we can ensure that certain developers can focus on the low-level plumbing while giving everyone else the flexibility to build for their particular use case. And so it saves time and it also facilitates industry standardization. So it's important that the ecosystem has it's important that the ecosystem develops standards around various aspects of user identity management, data encryption, of course, the mechanism by which an application can request that a Bitcoin transaction be created, and digital signatures, digital identity certificates. All of these things are important components for the future of the Metanet, which is essentially Web3. And so the applications that utilize a standard approach to these things can be largely interoperable. So our role is to facilitate that interoperability and thereby enable an ecosystem of applications to emerge that benefit from a shared value network, meaning that when somebody signs up to one of them, the friction for them to use other applications in the ecosystem is significantly reduced because they already have established a Metanet identity, which is local and held by them on their devices. And then applications can simply plug into that in a standard way. So we've defined the protocols that facilitate the operation of that sort of shared identity interface. And then our role is to educate developers like you guys on the best ways to utilize the tools that we've created to facilitate applications that utilize that identity, and then also to facilitate understanding of the low-level components so that developers wishing to specialize in the infrastructure, the plumbing, the lower layers of the technology stack can gain the experience and sort of architectural awareness necessary to add value in that space as well, because we don't want to be the only infrastructure provider. We want to see a set of shared standards emerge across the ecosystem for the ways in which this is done, but in the same way that different web browsers such as Chrome, Safari, and Firefox all provide access to the same web APIs, we don't want to be the only Metanet identity provider, and we don't want to be the only Bitcoin infrastructure company. We want to see a redundant ecosystem emerge such that it's resilient to any single company failing, and the architecture would continue to exist for the benefit of the ecosystem. So for those looking to specialize in building on top of the blockchain and utilizing blockchain as a service within their applications, or utilizing essentially protocols that enable transaction creation, the exchange of encrypted data between users and things of that nature, our role is to give you the tools that you need in order to do that, and to allow you to understand the utility in building with our architecture, as well as potentially providing you a way to suggest improvements to the architecture while it's in its early stages, so that we can we can be adaptable and solve for all the different use cases that exist at the sort of protocol layer and at the standards layer. And then for those of you looking to specialize in Bitcoin infrastructure generally at the lower layers, our role is to answer any questions about the design decisions that we've made with the software that we've created, as well as to provide access to the tools that we've developed and help you help guide you as you perform research into the ways that those tools work and the use cases that they can solve for on top. So that's a high-level overview from an architectural perspective. I would say that from a business perspective, the pitch that we make to app developers is that we make it 10 times faster and cheaper to create things on top of Bitcoin, and we reduce your time to market for such applications. And then I would say from the technical side, I mean, Braden, have I missed anything? Are there any holes? Should I go into this specific architectural components at this point, or should we take some questions from the group?
Let's go to high-level overview. I'm not sure if it would be best to do questions at the end, or if you just want to go into talk about a couple different areas specifically first.
Why don't we be dynamic here? With this high-level overview in mind of our role in the ecosystem and some of the things that we have defined thus far, are there any questions initially from the group? And if there are no questions, then we can proceed to specific architectural components and problems that we've solved, software that we've created, tools, how those things work, and how you might be able to use them. So any questions from the group at this point? Just, I suppose, just speak up, or we'll see how this works.
Okay, contributors, anything from your side?
You may post in the chat as well. I don't know what the best way is to engage. I know there's a large number of people on this meeting, so you're welcome to either speak up or post in the chat.
So we got one question. Can you tell more about a tool or tools you have created?
Sure. So yeah, we can proceed now into the next section. Then it sounds like. So when I started the company back a few years ago, I didn't really want to be an infrastructure company. I wanted to create applications on Bitcoin. So like everybody else back at the beginning, I wanted to build applications using it. So for example, I wanted to create an on-chain social networking platform. I wanted to create a system where artists could upload songs and get paid directly for their content, and that would facilitate a more fair experience for them. I wanted to create various different micropayment-based applications. And when I set out to do so, I found that the tools were not there yet and the infrastructure was not there yet from an architecture perspective to make that happen. So I did try to create several early projects in 2017, 2018 on top of the blockchain. But all of those projects failed for one reason or another due to essentially the lack of standardization and the lack of infrastructure support. And so the eventual conclusion that I made was that we needed to create a generalizable, reusable, modular set of infrastructure that facilitates those types of applications. And then we needed to achieve adoption for that architecture into the largest platforms so that those applications can be created and adopted by users. The philosophy that we take from an infrastructure perspective is we don't know what the killer app for Bitcoin will be, but whatever it is, we're going to make it 10 times easier to build it because there are a large number of common things to every Bitcoin-powered application or every application that leverages sort of the Metanet Web3, these new ideas around distributed ledger, micropayments, identity ownership, data privacy. And so there's a large number of sort of problems that every person who is trying to utilize those new technologies is going to face at the very beginning. And so by categorizing and thinking very carefully about the use cases that people have and the problems, the pain points they run into when they start to build an application on the blockchain, we've arrived at a set of tools and standard protocols by which we can solve those use cases from essentially bisecting into different layers of technology. So there's going to be the infrastructure layer, which provides the solution, and there's going to be the application layer that plugs into that infrastructure in a standard way and in a compatible way, such that as time goes on, multiple people can provide the infrastructure and solve the problem in potentially different ways, but it's compatible because of the communication mechanism being standardized between the applications that get built and the infrastructure at the lower layers. So this being said, I suppose the first thing that we ran into with trying to create an application would be key management. So when you want to build with Bitcoin, you realize pretty quickly that you need to create transactions, right? And that's a fairly common thing. And therefore you need to have, of course, a cryptographic key utilized to create a digital signature needed to unlock and manipulate the Bitcoins that you are dealing with. So to spend inputs and use them, right, to redeem previous UTXOs in Bitcoin, to create new outputs inside of Bitcoin transactions, we need keys. And the question emerges, who should have those keys, right? Should it be the users of the application? Should the users be responsible for managing their keys? Or should the application manage them on the back end? And if you make the application manage keys on the back end, there are some benefits to that, which is simpler user adoption, but there are also drawbacks because, as we've seen many times with cryptocurrency exchange hacks, when all the keys are managed on the back end and somebody steals them, then bad things happen. So we needed a framework for key management where users can hold the keys to their information. And we needed, therefore, a way to isolate those keys such that malicious users or malicious applications and malicious code, rather, wouldn't be able to compromise and use those keys without user authorization. So we also realized at this point that it's better if the user has one identity, which they can use across multiple applications, and then multiple applications can kind of plug into this one single identity, which is held by the user. And this means that as applications get built, they can benefit from a shared identity infrastructure and from a shared public key infrastructure, a key management infrastructure maintained by each of the users of that system. And so this means that we need on-device key management. So one of the tools that we've created is called the Metanet client, which is a piece of software that you install onto your computer, and it manages a set of private keys. It never exposes those keys to the applications because then the applications could compromise the keys or use them to create signatures without the authorization of the user. But it does put the keys behind a sort of firewall of sorts, if you want to think of it this way. So it provides a system in which the application can send a message to the Metanet client over some communication substrate and facilitate the creation of digital signatures, which can be used within Bitcoin transactions to enable these signatures to be created with user authorization, essentially. So some of the standard protocols that we've created define communications substrates, communications mechanisms between applications and the key management and transaction creation infrastructure as part of the Metanet client. And then we also sort of we enable the supporting, we enable a lot of other a lot of other things as part of the Metanet client as well. But I would say that's the main one, right? So applications send requests to the Metanet client and ask the Metanet client to perform various operations, whether it's the creation of a digital signature, the encryption of some data, or even the creation of a Bitcoin transaction, because the Metanet client will also manage the user's Bitcoins on device, and in such a way that it doesn't need to be segmented so that each application has its own balance. Really, the user has one balance, and this is the user's Bitcoins, which can be accessed and used across all of their different applications. So the Metanet client provides a central place for users to store small amounts of Bitcoin used for micropayments, as well as to facilitate Bitcoin transaction creation within applications. the creation of digital signatures, the management of digital identity certificates for such things as micro-credentials, which is one of the projects at TSoC. And there are other features as well, but I would say those are the main ones. And so the Metanet client is a tool that we created that when a user has it installed, then any application can plug into it. And this is an architecture that allows sort of applications to benefit from these features without needing to deal with things like key management themselves. So the first applications that I created simply had the user write down 12 words for every single application, and then they might lose their keys and there's nothing I can do, and it's not a good user experience. But in this case, when a user has one single set of keys which belongs exclusively to them and is stored on their device, and then all applications plug into it, then you don't have to have them write down 12 words or have some key management architecture on an application-specific basis. You simply have one single identity and then one single balance, and all of your permissions management is centralized into that one Metanet client where all applications can plug into it. Essentially, this is systems level functionality in a similar way that operating systems such as iOS or Android can provide permissions management for things like access to your location or access to your camera. We're defining the same thing, only extending that architecture to the entire user identity and all of the user's digital assets and their ability to actually transact directly with one another to exchange value. So that's the utility of the Metanet client. It looks like, are there any other, I'm reading the chat here. Other questions that are here that have built up? I'm happy to check in with the audience and see where everybody's at. Are you guys following? And do you have any other questions from this point?
Looks like there's one question related to talking about managing your identity with your public key. So it says, will the public key be available to everyone?
So the way that we have this set up is actually using a sub-key architecture. You have one root key, which is known as your identity key, and that is acting like a master key or some, but it's never used directly. Instead, you derive child keys, which are used within particular protocols to facilitate particular operations. So my root private key, and Braden, feel free to kind of jump in here. But essentially, the protocol ID and key ID architecture, right? Do you want to provide an overview of how that works, so that they can understand sort of the multiple public keys and how you have it there?
At a high level or like in depth?
Well, I mean, just at an in-depth enough level to get the points across in such a way that we can, we can get them to understand some things.
Okay. Yeah. So with ECD or ECDSA, right, or elliptic curve cryptography, you can do some cool stuff where you can derive keys, like sub keys, based on a root key, and so this allows you to not be reusing your root identity key for every Bitcoin transaction you want to create, and or encryption, which there could be some vulnerabilities with key reuse if you're reusing the same key over and over.
Mm-hmm.
And you can also derive keys per application. So like the protocol and the key ID, which are used as part of your key derivation, could be associated with a particular application.
Right.
So you can have like
so
a whole key universe.
Whenever you create a digital signature, or whenever you encrypt some data using one of a user's keys, you specify a protocol ID, which is the protocol under which the digital signature is being created, and you also specify a key ID, which is within that protocol, which specific key is being used to facilitate the creation or verification or the encryption or decryption of data associated with that, with the operation you're performing under that protocol. So there are some isomorphic properties of elliptic curves, which means that when you have a public key, you can stipulate some value n, and so you have your private key d, and I will provide some level of depth with public key cryptography, and perhaps people understand how this works. But your private key is D, and you multiply D by G using elliptic curve point multiplication, G being the generator point, and that arrives at your root public key. And then you have essentially D plus N as your derived child private key. And someone can derive the corresponding public key without knowing D by simply computing the D by G value plus N. So the point is you can make offsets from a public key. And so when I know somebody's public key, I can compute an offset, and then I can compute some derived child public key, which they can compute the corresponding private key. But even though I can compute some child public key using some offset, I still don't know which private key is associated with this. So for those that want to know more about how child keys work and how they can be used within this context, there is a few documents which you might look at. Braden, if you could provide links to BRC 42 and BRC 43 in the chat. There are some technical standards that we wrote that are available for anybody to research and understand and implement, and we're happy to answer any questions about them. But essentially, we're making use of the isomorphic properties of elliptic curves to facilitate an architecture in which key reuse, we don't have different keys that are being reused, and so it works out well. The user has one root identity key, but then for each of their operations and within each of the various contexts in which they are, creating signatures or performing cryptography, there are ways to ensure that it's not always using the same key. I suppose the other relevant component here is known as counterparties, meaning that when I am, for example, sending some data in an encrypted format between two parties, then I can also specify, in addition to the protocol ID and the key ID, I can specify a counterparty. And what this does is it uses a shared secret between those two parties as an offset to the recipient's key. And so at a high level, what this means is that you can do secure data exchange within shared key universes. So only the two parties involved with the transaction can perform the necessary key derivation operations to access the derive the correct child keys and be in the know about what is happening with this operation, because those are the only people who have been given authorization to be party to those exchanges. So there's lots of different things that can be done using child key architectures, but BRC 42 and then afterwards BRC 43 are some useful standards that you might look into if you'd like to learn more about that particular aspect of the system that we have defined.
Yeah, there's a couple of questions.
Okay.
One about how does the Metanet client achieve these isolated environments? Where would the keys be stored on the device? Does it interact with trusted execution environments on Android/secure enclave on iOS?
We haven't defined support for those types of low-level hardware-based sort of environments yet. However, it is on the roadmap such that the Metanet, we believe fundamentally that keys should be managed in hardware, and we don't want to make them available to different applications. Right now, when you install the Metanet client on Windows, Mac OS, or Linux, it will save the private keys in a somewhat obscure format, but in a way that fundamentally is simply just a file on the hard drive. And we don't think that's the best approach long term. We would like to see support for doing isomorphic cryptography using ECDSA within things like HSMs or TPMs on the device to facilitate that type of operation. But unfortunately, even in iOS, the secure enclave doesn't support the type of isomorphic cryptography needed to derive child keys and compute shared secrets with counterparties, et cetera, necessary to enable the secure exchanges of information. I found this surprising when I first learned about it, but there needs to be greater support at the hardware level for these types of things. There needs to be greater communication between device vendors and infrastructure providers in order to arrive at a standard approach for doing this in hardware. And that's something that we want to facilitate going forward, but it doesn't yet exist. So therefore, we're forced to relegate our key management to software, and we simply do the best we can with the tools that we have to store the keys in a secure way. Of course, it's difficult within something like an application sandbox for iOS or Android, wherein the application, if it's malicious, may be able to try to compromise the keys. And so we're exploring different ways to integrate at the systems level, hopefully, because that's really where this functionality belongs, right? It belongs at the operating system level, such that applications don't have authorization to perform unauthorized actions with user-held keys. And as time goes on, we think that support for these types of standards will emerge within large platforms. But for the time being, our approach is simply to store keys in a way that makes it difficult to access by applications, to be aware of which applications are using the tools and systems that we create, and to make it very clear that compromising user keys is a violation of the law and is essentially under the Computer Fraud and Abuse Act. It's you're exceeding authorized access to protected computer systems by doing this. And so there's some legal protections. There are some small amount of technical protections in place, but going forward, we believe the keys should be managed in hardware, and we hope to enable that as time goes on by working with device vendors and whatnot.
Another question was, can the root key be derived from the child key, which I think you already addressed.
Yeah, you can derive a child key from a root key. Going from a child key back to a root key is not. I don't believe you can derive a root key from a child key. Like if I have some child key for a user, I can prove linkability if I know the root key, but I can't learn the root key just because I know the child key.
Yeah.
All right.
If we go back up, kind of an off-topic question is: are these tools only integrated with the Bitcoin blockchain, or can we integrate them with Ethereum and Polygon as well?
So currently, we don't have support for other blockchains. Fundamentally, I believe that the economics that underpin some of these blockchains may not be sound, but we are fundamentally a Bitcoin SV platform. Some of our, I think it's best that there is one blockchain, and Bitcoin SV provides a UTXO-based model, which I think is important for scalability. I would be happy to have a discussion at some point, perhaps in another forum, about the scalability implications of account-based versus UTXO-based blockchains and some of the finer points there. But I think that fundamentally, having one central blockchain that everybody kind of plugs into as a single source of truth for data, and having that be a UTXO-based ledger can enable things like BRC9, which is a system for verifying transactions that you receive without needing to rely on trusted blockchain scanning or indexing systems, so that participants can have the greatest degree of confidence possible in the data they are dealing with. There are different approaches to architecture and approaches to the blockchain as the industry grows, but we hope that our contributions are going to be useful within the context of Bitcoin SV. Other questions? Should we go back up? Should we kind of look at some of the other tools and systems that we've developed aside from the core Metanet client, and then maybe proceed with some further information sharing about some of the some of the other areas that we make it easier for application developers, such as authentication, content distribution, things like that.
I have a question for you.
Okay. Yeah, proceed.
So how do you, execute the security measures through Project Babbage to ensure that the data integrity is protected? Like, what is the security measures that you have, you are using right now?
So when a user creates an identity using our Metanet client, they essentially create a key, a root private key, which is which underpins some of the aspects of their identity. So that root private key is used to create digital signatures and things like that within applications. When an application sends a request to the Metanet client via one of the communications substrates, which facilitate communication between the Metanet client and the applications that use it, the Metanet client will pop up on the user's screen, and it will ask the user in a sort of asynchronous manner whether the user wants to permit this operation to proceed. So by prompting the user and by defining a robust architecture around permissions management, we can ensure that the operations that applications perform are authorized by the user prior to executing those operations. So some of the operations that you can perform using the Metanet client include requesting that a particular piece of data be encrypted by a particular key within the context of a particular protocol, or requesting that a particular digital signature be created, or requesting that a particular Bitcoin transaction be created which contains a certain number of Satoshis as within output scripts, and facilitates, obviously there's an amount component there. You're authorizing the spending of a certain amount of Satoshis from your Bitcoin balance. So all of these different operations have different implications in terms of the sort of what is authorized and at what level. And so we've defined the permissions architecture within the context of BRC 43, which Braden has linked, which enables different protocols to have different permissioning security levels, because certain things are more important than others. For example, the protocol that governs the digital asset that represents the title to, for example, a vehicle, might be a more secure and locked down protocol than something that, for example, governs a token that represents a little hat that you can wear on a game or something. So there is support fundamentally for differing protocol security levels, and some protocols require no security, meaning that you can simply use them, while others that utilize different sets of user keys are more locked down. And so because the child keys are derived using the protocol name as input, it means that when a user when an application requests to use a particular protocol, that operation is defined within the context of a particular key universe, and only that key universe is sort of made accessible when a user grants a particular permissions request, so allowing that application to perform that operation. So by defining a robust permissions architecture that intelligently sort of that accounts for the various different use cases and the different security models that exist, we have created a system that allows users to be in control of that type of operation.
Got it.
And we've also specified that the behavior that we expect from the Metanet client, as well as from the application in terms of managing that type of thing within open documentation that is accessible to everybody here. So if you're curious about, if you'd like to perform some of your own research into the architecture that we have created, or if you have more questions about that type of permissions management, we're happy to discuss it further and improve the system as time goes on.
Yeah.
Other questions? Should we proceed to the other components of the system, or how are we doing on time? What are you guys' thoughts? How is everybody doing?
I want to engage the crowd, so I want them to ask questions, because if you pour out all the information and if they don't understand,
Yeah.
there will be a problem.
Yeah, I don't want to. I kind of want to make sure that everybody's understanding some of the things that we're creating. If you don't understand, please let us know what you don't understand so that we can provide the relevant information and so that we can explain things in a way that makes sense. I don't know whether a lot of this information is being received by everybody, or if you guys are struggling to understand. So please let us know if you don't understand something, and we are happy to provide more information and context. Yeah, I'd like to how engaged is everybody with this process? I'm curious as to sort of some ideas that people have. Maybe they are trying to build an application, and perhaps this software would make it easier for them, or what are some of the do you guys see value in the system that we have created in terms of an architecture for application development? I'd like to kind of open up to see if anybody from the group has any comments or thoughts before we proceed.
You know what? Let me get straight to the point. If I was a developer and if I hear something about Project Babbage, then I would be very curious to know how I, as a developer, would be able to contribute to it. So can you just walk us through that? How, as a developer, I can contribute to Project Babbage? I think you'll have some STE, right? STE toolkit or something. I read about it.
Yeah, so as a developer, I think that the main way that you can add value to the industry is by understanding the architecture and the tools that we have created, and then using them to create different applications on top of the system. Because what that will do is it will grow the ecosystem of apps and users that are benefiting from the technology, and therefore it will make the ecosystem more valuable and increase the network effects. So if you have an idea for creating an application on top of Bitcoin, then you should tell us about it, because we can show you perhaps some of the ways that you might go about architecting your application using our tools, and we can show you how our tools can be useful in defining your application architecture and facilitating its operation in the most efficient way possible.
Okay.
So our customers are developers. Like, if you want to build things with Bitcoin, then this is like how you can do it, and that's that's essentially what our pitch is.
Yeah, we've built like an SDK, right? That developers can use like in their React apps or different web apps, and it's just a JavaScript library that you can just plug in and easily create Bitcoin actions or transactions. You can encrypt data, and it just connects automatically to the user's Metanet client when it's running on the computer over a standard interface.
Yeah, and I've put a link to some documentation in the chat. So if you go on there, you can see a quick start guide. You can follow a tutorial to create your first application using the Project Babbage toolset, which is a to-do list that utilizes UTXOs to track to-do list items, and then redeems them as you complete them, unlocking the tokens that you have put into it. So that is a simple tutorial to help you understand Bitcoin tokenization, and also how to use the Babbage SDK to create Bitcoin transactions and also redeem them. You also understand fundamental components of transaction creation, such as change output generation, input selection, and some of the ways that Babbage makes that process a lot easier. So if you want to follow along, you can go to that link, and you can see a getting started guide, and you can also see the Babbage the to-do list tutorial, I believe, is on that page as well, and you can follow along. Definitely, please reach out to us if you have any questions as you follow along with that tutorial, or if there are things you don't yet fully understand, and we can update the tutorial to provide the relevant information, because we want to make it as easy as possible for people learning the technology to go through the process of creating their first application and facilitating the first exchanges of value between users of their application through the the ecosystem that we have defined.
So Shubham here has a question. What are the other tools and protocols you are making apart from Meta client?
Yeah. So the Metanet client is essentially the core of our system, right? We have used this to define a framework for creating Bitcoin transactions, managing permissions, encrypting data, and dealing with identity certificate management at the fundamental level. It's the base layer, right? It is like the foundation on top of which we can build other things. And then we find that we can make much greater progress, and it's much easier to create things once we have defined this foundation. So after we've defined the Metanet client as the foundation for the architecture, and after applications can plug into it, and once those premises are made, then we're able to define such things as mutual authentication between parties without the need for passwords. We're able to define such things as the exchanges of value via micropayments between parties using very simple tools that integrate with existing web technologies such as Express middlewares. There are many different things that you can do on top of it. Also, things like content storage and distribution in a distributed manner across your application. So, for example, if you upload some content such as a song or some photo or some video, you can register that content on a distributed, essentially it's similar to a distributed hash table or DHT, but it facilitates a robust architecture for the availability of that content. So those are three areas that we think are really important and really useful across a generalizable set of applications. So therefore, we have defined some fundamental tools that enable that type of functionality on top of the Metanet client and within our ecosystem of applications and services. So the first one that we can talk about would be authentication. So in order to have authentication between parties, you have two choices. You can use passwords, which are inefficient and also prone to issues, and then you need to use other systems such as TOTP or multi-factor authentication, which can be annoying and cumbersome. Or you can use digital signatures. But the problem with digital signatures from the past is that there was no standard way to create a digital signature from a user. But in our case, because we have the Metanet client now, we have defined precisely such a standard. And now there is a way for users to create digital signatures, and those digital signatures can be used for authentication. So one of the tools that we've created is called Auth-Write, which is a system to allow users to establish mutual authentication and to facilitate that type of interaction between parties. Then I can know who you are, and you can know who I am, and we don't need to have any passwords, and it's all done in a standard way, and then we can solve it for the general case. So any application will be able to verify the authenticity of the users and of their peers. Like if I communicate directly with Braden or something, then Braden and I can both have authentication. So I know who Braden is, and also Braden knows who I am. And this is done in a way that does not require passwords. So Auth-Write is a system for mutual authentication that utilizes the Metanet client. And if you're building an application that requires authentication between parties or authentication with your backend server, then you can use Auth-Write, and it enables it in a very seamless and effortless way without the need for passwords. So that's one tool that we've created on top of the Metanet client for use within our ecosystem. And there are other tools as well.
Yeah. And one cool thing about Auth-Write too is when you're building an application that needs to communicate with the backend, a lot of times you use this standard fetch library to do that, like window.fetch.
Mm-hmm.
But what's cool is Auth-Write is a drop-in replacement for that. So you can just modify your existing React app and just drop and replace, instead of saying window.fetch, you just say auth-write.request. And then it automatically adds authentication that plugs into your Metanet client. It's very easy.
Mm-hmm. So there's a lot you can do with Auth-Write as well in terms of identity certificate attestation and management. So Auth-Write does not only provide access to authentication of users and tells you who is the identity key of the person who you are communicating with and provides an authenticated channel for such communication, but it also facilitates identity certificate exchange. So if I want to request for you to provide me with some certification about, maybe some skill that you have, or maybe some legal document for your make sure you're over 21 or something, then I can facilitate that type of thing in a standard way that defines. There's a negotiation protocol where everybody can choose what they want to provide and how they want to provide it, and then it works across all of the applications that you have built. So that is Authright, and that is one of the tools that we have defined on top of the Metanet client for use within our ecosystem. And I think that it can be useful. Does anybody have any questions specific to Authright, or shall we proceed to the next tool, which is related to micropayments?
I'm excited to learn more about the micropayments tool.
Yeah, okay. So Packet Pay, essentially, is the name of our tool, and it is also a drop-in replacement for window.fetch. Does anybody in the audience know what error code 402 is? HTTP error code 402? But it was never implemented? Does anybody want to have any guess? Like, there's 404, which is not found, right? 401, unauthorized. But 402, do we know what that is? It was from the 90s when it was first defined. Early 90s, actually, but nobody built it. So if nobody wants to have any guess, then 402 is payment required. And it means that the server is requesting that a payment must be attached to the request in order for the request to succeed. So we have utilized error code 402 to create a system for micropayments for HTTP requests. And then you can have some middleware, which you install on your server, and it will see what is it'll see what route you're using, and it can determine a price for that route, which can be 0, or it can be some number of satoshis which you want to receive for use of that route. And that can be used to define micropayment-based monetization for any API or backend system which you're building. So we've defined this also in an open way, and the payment protocol can be viewed. I believe BRC 41 is the instantiation of the payment protocol for use within HTTP. And then also BRC 29 is the core payment protocol, which facilitates the exchange of value and the processes around that. So different BRCs, Braden, if you want to link to BRC, I think 41 is the important one here.
Okay.
Essentially, this is also a drop-in replacement for window.fetch on the client, and it enables micropayments as well as authentication, because Packet Pay is actually a tool that is built on top of Authright. So we have different layers of technology that facilitate different things. And this can be useful within your application if you want to monetize your API, or if you want to exchange value between parties. So one example application that utilizes Authright and Packet Pay is a tool that we, or is an application that we demonstrated at the London Blockchain Convention called BotCrafter. So botcrafter.io is an application that we created using our architecture, which is an NFT marketplace for AI chatbots powered by ChatGPT. And I will link to this as well. So that is the application that we have defined in this way, and it makes use of these tools. So Authright and Packet Pay are both used in that application, and the code for that application is also open source. So I can provide a link to the code as well. Give Crafter dash front-end, right, Braden?
I believe so.
Right, so I provided some links as well to some source code, and you can see an example of how these tools are implemented within the context of a React application that uses an Express server as a backend. So any developers, if you understand about React or if you understand about Express, now you can add micropayments and authentication to your applications using the Metanet, using Web3, and using digital signatures without the need for passwords, and you can integrate it with your existing knowledge and tech stack. So I hope that's useful to you. Let's see. Are there any questions before we proceed? I mean, I can talk about NanoStore and everything else, but I feel like these are the main components that we've defined, and that'll be kind of bringing things to a close.
There are no questions, but there is a comment. I will surely check out, authorize, and implement it in our project, micro credentials. So
Yeah, for
you
sure.
were
Nice.
present at the session yesterday.
hmm I was happy to see that you are building something that is so closely aligned with some of the technology that we've created. And I think that BRC52 identity certificates provide a useful vehicle for the conveyance of micro-credentials between parties. So I think that you'll be able to make use of that. And I'm happy to provide any guidance on implementing that into your use case. Just let me know on Discord or something, and we can talk about it more. Okay, so yeah, those are some of the high-level components that you can make use of within the architecture that we have defined. The final one, I suppose, we can talk about is NanoStore. So I'll just provide a link to the main marketing page for NanoStore. Links to the documentation as well. NanoStore is a system for tracking content. I kind of alluded to it briefly, but essentially, at a high level, it facilitates the user being able to upload some content, such as a document or a song or some type of thing like that, and register it in a way that is robust against single host failures. So, for example, if I go and upload something to Google Docs right now, and if Google Docs goes away, then my content might be lost. But by registering the hash of the content on the distributed ledger and then facilitating a protocol by which at the protocol level, the hash can be resolved by multiple hosts, and then by paying multiple competent hosts according to the level of redundancy that I require and the amount of expense that I'm willing to incur, I can create, I can facilitate the exchange of that kind of content in a robust way, which means that as time goes on, if one host goes away, there are other hosts available to provide that content and to resolve that hash. And because it's a hash-based content resolution system, it means that anybody can easily verify the content they have downloaded is correct and is responsive to the request they made, and it's not some wrong document. So it also provides tamper evidence, meaning that nobody can change the content that was originally uploaded because it's using a hash to verify it. So NanoStore provides the ability to manage multimedia content, including photos, videos, music, even augmented reality objects or some silly thing like that inside of your application which you're building. And we have facilitated the operation of that network, and we have defined protocols that make it usable for anybody. We don't want to be the only person to host this kind of multimedia content. We want to see the emergence of other people who will also host it, so that we achieve a resilient network of content storage and retrieval. And so the protocol supports this fundamentally at the base layer, meaning that as people use the system more, the system will become more resilient and it will facilitate the most efficient exchanges of content between parties. For example, if I know that there are 10 people that host a piece of content and they're geographically distributed across the different continents, then I can request it from the one who is closest to me, and they can provide the least amount of latency and also the lowest amount of networking costs to move the content the shortest distance to its intended destination. So each party can independently decide which of the hosts they would like to use for requesting the content, and they can create efficient architectures based on those decisions. So these are just a few of the systems that we have defined on top of the core Metanet client and identity infrastructure for Web3. But I would say that those are the most important ones that you should learn about as you start to build and make use of these tools. So I wish you good luck on the projects that you're building throughout this program, and we are available to answer any questions and provide you with research guidance as well as implementation support as you build your various use cases. I think you guys are building some extremely valuable things, and we're happy to once again be a part of facilitating that experience for you. And hopefully we can show you that you don't have to reinvent the wheel for each of these things. And maybe you'll find that because the industry has started to standardize and use these tools in a way that makes the most sense, that your work might be easier. And also then you can focus more on making your work better and creating more value for the people who you're trying to serve, because then you don't have to get caught up into small details such as generating change outputs that use different addresses for Bitcoin transactions, or selecting the best inputs to use in your Bitcoin transactions. Silly things like that are something that should be relegated to a lower layer of the technology stack and allow application developers like you guys to focus on creating your best use cases. So that being said, I think that that brings my presentation to a close in terms of what we offer and the most important tools. I would emphasize there are many other tools that we've created that I didn't have the time to cover, but I think that for a basic session, just providing this simple overview of the most important things will allow you to get the most value out of things quickly. So therefore, please let me know if there's any other questions that you have for now. Otherwise, we can draw the session to a close, and I will make myself available, as well as Braden here. We'll both be available to you, and there's other members of our team that we might bring on board as well, depending on the number of questions and the amount of engagement that we see from the participants. So are there any other questions, or shall we bring things to a close now?
Shubham wants you to share the links of all the tools that you have built apart from these three.
I can put a link
Okay,
to the product page.
maybe you know what? Maybe can we include all these links on our Discord? I'll make us. I mean, there is already a channel called Blockchain Resources. So maybe we can, link all these tools in that channel itself. And I have given all the mentors the access to input their details, so that input the resources there. Only the contributors can view. So maybe we can include it in that channel itself. I'll tag you too in that channel, and you can drop the links of all the tools there itself.
Yeah, Braden, if you can
Which channel
get
was
links. Blockchain Resources, right?
Okay.
I'll just tag you right now.
Can you not hear me?
Yeah, we can hear you.
Oh, okay. Yeah, I was just trying to find the right channel. I see.
I'm tagging you.
Okay.
Yep. So Braden will
Okay.
provide the links to those
Yeah,
resources, and they will be made available through your guys' Discord server, so that when you when you go on there, you'll be able to access them. And you can also tag. You might tag Braden on Discord, and he can let me know also. I'm not as active on there, but either way, tag us both, and if you have any questions, and we will be sure to answer. Help you guys build this stuff out. We're available to, like I said, provide guidance in that area, and we think that this is going to be an exciting program for you, and you'll learn a lot, and really start to create some value on top of this ecosystem. So. Thank you guys very much. I think we'll end here. But yes, links to those things will be on Discord.
Yes. Thank you so much, Ty. Thank you so much, Braden, for joining us in this session and giving us all the insights about Project Babbage and how you all are trying to revolutionize the internet. And the amazing products that you all have come up for developers to build scalable and secure dApps. So yes, that's about it. Just one question.
One question?
To
Okay.
ask, what drew you towards Bitcoin? Because both Ethereum and Bitcoin were proof of work, right? They were following the proof of work consensus. So the scalability factor.
The scalability of UTXO-based blockchains is significantly greater, in my view, than that of account-based ledgers. The need to trust centralized chain scanning and indexing system puts a fundamental limit on transaction capacity in account-based systems. And so by using a UTXO-based architecture, you can simply verify the Merkle proof on any transaction you receive directly from one of your peers, and that doesn't put a limit on scalability, because everybody can independently verify the veracity of incoming transactions. And UTXO lookup services can emerge that facilitate the sort of validation that something isn't a double spend, for example. I think there's also a lot of potential that I haven't really gotten into on top of the technology for doing things like overlay networks. So overlay networks facilitate another level of functionality that is even greater on top of this technology. And we've been actively involved in researching the best ways to implement that. But I don't believe that it's possible to do things like that using an account-based system, especially one that is constrained by transaction capacity and high gas fees and things like that. I know that things like Polygon have tried to reduce the costs of transactions. However, I also believe that it still is like at least 1 US cent per transaction. And so by using a system that charges, perhaps 2 orders or 3 orders of magnitude less per transaction, we'll be able to facilitate 2 or 3 orders of magnitude more value exchange. And therefore, that is my reasoning for choosing a UTXO-based blockchain. And so I would advocate the use of Bitcoin SV for all use cases, because I have yet to find a single use case where an account-based system outperforms a UTXO-based system. And also, if you have a system that you believe you cannot build using a UTXO-based model, such as Bitcoin, then I will be happy to discuss it, and maybe we can talk about some architectural designs for your use case. So please consider the use of UTXO-based blockchains because they are fundamentally more scalable and provide lower cost transactions. I think that would be my answer. I mean, I think, it's hard to say, like, we don't know what the future holds, and there's so many different things in the industry, but everybody will, everybody will build using whatever system they choose, and we'll see which ones create the most value. And these are my beliefs, but I'm sure there are others who believe differently. And in that case, I mean, that's fine. We don't have to agree about it. It's just there are different architectures that exist, and we can, my role is to create value using the architecture that I have defined and that we are utilizing within Bitcoin SV. However, if you would like to discuss this further with me privately, then I'm happy to let you know about more of my thoughts on the scalability of the account-based versus UTXO-based architectures.
Yes, sure. That would be amazing. So yes, that's about it, guys. If you all have any more questions, any more doubts, to Braden, to Ty, they are available on Discord 24 hours into 7. So yeah, that's about it. I guess we can conclude this amazing express session that we had today. And good night, contributors, and have a great day, Braden and Ty.
All right, thank you very much.
Okay, talk to you guys soon.
All right.
Bye-bye.